Everyone, welcome to Almighty Tricks. There is a question in LeetCode saying single number 3. So this question is the one of the question from the single number question series. So I already discussed 2 questions from the single number series. So you can check those things. So in this question, it is asking like in we have given one array. So in that array, there will be some duplicates number. Duplicates number, I mean one. Let's say one. There are two ones are there. There are two twos are there, but the two numbers which are not repeated. Okay, so those two numbers we need to find. Okay, and it is saying we need to implement in linear time complexity and constant space. Okay, so let's get into the notepad. How we can solve this question, let's check. Okay, so let's say the question is given like this. The question is given, so A is an array, given array. So question is 3, 4, 3, 5, 4 and 7. Okay, so the output should be like this. So output should be 5, 7. Okay, in an array. Okay, so if you see 3, there are 2 3, there are 2 4, but 5 is 1, 5 is 1, 7 is 1. So we need to find these two identical numbers. So so the approach, the basic approach, I can say like we can have hashing technique or hash map we can use. Okay, so in the hash map we know we are saving key value pair, right? In the key value we need to have in the key we can have 3 and the number of repetition, 4 number of repetition, 5 number of repetition, 7 number of repetition. So then we can return this two, right? So but this approach will take linear time complexity. It will take linear time complexity, but space complexity also it is taking big of and space. Okay, but we need to solve it in constant space. Okay, so let's check that one. So approach 2. So before going to the approach 2, we need to understand the basic operation for the bit manipulation. Okay, so we know 2 jot 2 is what? 0. Okay, 3 jot 2 is what? 1. What I mean? 1 0 1 0. If I take the jot, then it will become 0 0, right? Similarly, if I take 1 1 1 0, if I take the jot, then it will become 1 and it will become 0, right? So it means what? A B A jot B 0 0 1 1 0 1 0 1, right? I can write like this. So it will become 0 0 1 1 0, right? Another thing is how we can let's say there is a question to represent n in negative. Okay, let's say n is given as let's say 2. Okay, so how can I write this in binary? So let's say uh, there is 8-bit representation, so I can write it like this: 0 0 0 0 0 0 1 0. So 2 I can represent like this. So to make it negative minus 1, minus n, so we need to do one. We need to follow one rule. Like first of all, we need to convert it to 1's complement. Then we need to add plus 1 with it. Okay, what I mean. So let's say n is given 2. Okay, so if I represent in 8-bit manner, so 0 0 0 0 0, then 0 1 0, right? Then I need to do the 1's complement, so it will toggle 1 1 1 1 1 1 0 1. Then I need to add plus 1 here. 0 0 0 0 0 0 0 1. So finally it will, so if I add this, so it will become 0 1 1 1 1 1 1 1. Okay. So if how it is become minus 1 minus 2. So basically in this scenario the MSB part should be treated as negative. Okay. What I mean, minus 2 to the power 7. Okay. It means what? Minus 128. Then all this thing will be positive. So it will become, if you calculate, it will become 126. So if I add these two numbers, then it will become minus 2. Okay. Okay, now we get into the actual solution. Okay, the actual solution will be very easy. So what we can do, so you so I already solved one question related to this single number. So where it is given 2 2 3 1 1. So we need to find the unique one. So what I did that time, so I did 2 to the power 2 to the power 3 to the power 1 to the power 1. So this two will cancel, this one will cancel, we'll get 3, right? So same concept will be using here. So what I mean, so I have this number, right? 3 4 3 5 4 7. Okay. Now what I'll do, I'll take jar for all the elements. 3 jar, 4 jar, 3 jar, 5 jar, 4 jar, 7. Right. Now 3 3 will cancel, right? 3 3 will cancel. 4 4 will cancel. Now we have 5 and 7. Okay. So we have 5 jar 7. So what will be the value? So it will be like 1 0 1 1 1 1. Jar will take. So it will become 0, it will become 1 0, so it will become 2. So 5 jar 7 is 2, right? Now here basically we have 5 7, but we are getting 2. Okay, we are getting 2, but from 2 we cannot we are unable to find what are these numbers. Okay, so we need to logically we need to check and we need to find the 5 and 7. So let's check it on how we can do that. Okay, so for that I can do like this. I can do one thing. So if you see here 1 0 1, this is 5, right? This is 5, and for 7 I can represent like this, 1 1 1, right? So if I take the jar, so that time this is become 0. This bit is become 0. So bit acts like 0, 1, 2. Okay. This bit will become 0. But this bit will become 1. Right? This bit will become 1. And this bit will become also 0. Okay. So if you observe one thing, we are getting 1 here. Okay. For different bits, we are getting 1 here. Okay, so obviously as we are using jar, so we will get 1 here. Write in like binary form this array, so I can write like this: 0 1 1 5 4 7. Okay, now so now I can do one thing here. I can have two buckets. Okay, I can have two buckets. Okay, so in this bucket I'll store one's one's bit, one bit. Okay, and zero's bit. Okay, or you can say set bit and you can say this one unset bit. Okay, the set bit in the from here basically we can get to know the which one is the set bit. Okay, so this is the set bit, so our index will be the our bit will be 1. Okay, this index. Okay, so we'll check whose bit is 1. First bit is 1, 3, so I can move this 3 to here. Okay, is 4? No, this will come to unset bucket. Here 3, yes, it will come to here. Here for 5, no, it will come to unset bit, unset bucket. 4 also it will come to unset bucket. And here 1, yes, it is set bit, so it will come here. Okay, so if you observe here, so we are getting 337 in the set bit bucket and 454 in the unset bucket. So uh, if I take jar here for this for these elements, if I take jar here and if I take jar here for these elements, then I think I'll get the value right. 3 jar 3, okay, 3 jar 3 jar 7. Okay, so 3 is cancelled, it will be 7. So 4 jar 5 jar 4, 4 is cancelled, this will become 5. So we are getting the result, right? So we are getting the result. So let's code this one. How we can code this? Okay. So I can have um, like int out, which will have the output. So we can have only 2 elements, right? So new integer array. Okay. int 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 n size of the array, dot length. Okay, now what I can do, I'll take first jar, right? Jar 1, let's say 0. What I mean to get this. Okay, so I'll take for loop. For loop will go I equals to 0 to n. Okay, and I'll take the jar equals to a of I. So I'll get the jar 1 here. Okay, now the question is how I can find this, how I can find this bit. Okay, to find this bit. Okay, so what I can do, I can do one thing. So this is 2, let's say this is 2, right? N is equal to 2, right? N is equal to 2, so I can represent in 8-bit manner like this: 0 0 0 0 0 0 1 0, right? Now if I take n minus n, means minus 2, so how I can write? So I have already explained here, no? Here, like this we can represent, like so. So I'll write like this: 1 1 1 1 1 1 1 0. Now what I need to do, I'll take the end for this. Okay, let's take end. So it will become 0, it will become 1, right? 1 and 1, this one. Okay, now this is become what? 0 0 0 0 0 0. These bits are like 0 1 2 3 4 5 6 7. So we can find the which bit we need to target. So this is the bit. Okay, so for that we can write like this. So int index idx jar 1 and with minus jar 1. Okay, jar 1 this one, and with minus jar 1. Okay, now we need to divide the buckets, right? These buckets we need to divide. These buckets we need to divide. Actually, we no need to have separate bucket or separate space or separate array. We can have, right, in the int, let's say value is a is equal to 0, int b is 0. Okay, what we'll do, without saving all these elements in a bucket, we'll directly take the jar. Okay, we'll directly take the jar. So what I can do, for loop int I is equal to 0 till n. Okay, here I need to check if a of I and with this index idx, okay, equals to 0. Okay, this one what I mean, let's say my idx is 1, right? Idx is 1. So here from here the idx value I am getting 1, right? So now let's say a of I is 3, 0, 1, 0. I'll take AND with this. Okay, so 0, 0, 0. So we are getting this, right? 0. So it is checking this bit is 0 set or unset. As it is set, as it is unset, so what I'll do, I'll jar with the actual element. Okay, a of I. Else it is, else means it is set bit, right? Then we jar with a of I. Okay, now it is done. So we found the a and b, the actual answer. Now what I'll do, out of 0 is equal to a, out of 1 is equal to b, then I'll return out. Okay, so this is the complete solution. Okay, so the time complexity it is taking, linear time complexity, and space complexity, and we go for one constant. Okay, so let's code this. We'll check whether it is working or not. Okay, I'll take int and size of the array nums dot length, then int jar1. Okay, initially it is 0, or I'll take the nums of 0. For loop int I equals to 0, I less than n, I plus plus. So jar1 will be like a of, sorry, nums of I. Right here we'll get the jar of the unique 2 values. Okay, then I need to find the index idx. Okay, jar 1 and with minus jar 1, I'll get the index from here. Right, now I'll take a equals to 0 for set value in set bucket, and b is for unset bucket. Okay, then I'll take for loop int I equals to 0, I less than n, I plus plus, if nums of 5 and with idx equals to 0, then it is unset bit, else it is a set bit. Okay, so a jar with nums of I, else b jar with nums of I. Okay, so we got a and b, Now we need to return int out, which will have length is 2, because we need to return 2 output. 0 is a, output of 1 is b, then return out. Let's run this. Okay, submit. Okay, it is working. Hope you understood this approach. Thank you for watching this video.